Hi, welcome back. We've talked about the biology of neoplasia. We've talked a bit about how cancers interact with their host body. Now we're going to talk about why cancers cause illness and death, so the morbidity and mortality of cancer. We will break this down into kind of 4 different areas. Paraneoplastic syndromes are first up. We'll talk about local growth and invasion. We'll talk about metastases, and we'll talk about the effects of therapy. And all of these play in, again, to the morbidity and mortality that we see with malignancy. First up is paraneoplastic syndromes. And really what this means, technically, is next to the neoplasm. It's paraneoplastic. But what it really means is that this syndrome, or these syndromes, because there are multiple, are caused by or result from the presence of the cancer in the body, but not the actual physical presence of cancerous tissue in the part of the organ affected. So that means that there are things being released by the tumor into the circulation that are causing effects at a distance. And that's what we refer to as a paraneoplastic syndrome. Circulating bioactive products. There are several different kinds of paraneoplastic processes, and it's also important to know that they can come from both benign tumors that are not considered malignant and don't have a lot of genetic instability, but also from malignant tumors. And I'll try to emphasize both as we go through this. So there are 4 general paraneoplastic processes that we're going to be talking about. There's anemia, there's hypercalcemia, hypercoagulability, and cachexia. And we'll cover these each in turn. Anemia is first up. And anemia is actually multifactorial and is a very common paraneoplastic manifestation in malignancy. So a variety of things can cause inflammation. As you see on the ends, infection and immunotherapy, but cancer is what we're talking about here, causing inflammation. That inflammation systemically will release interleukin-6, IL-6. That acts on the liver. The liver is responding to IL-6 thinking, gee, we're under attack. We need to do certain things that prepare the body for a microbial onslaught. One of the major proteins that is going to affect the hematocrit, the levels of erythrocytes, is going to be hepcidin, small molecular weight peptide synthesized by the liver, whose role is to regulate iron levels systemically. And when the liver sees interleukin-6, it cranks out hepcidin, which decreases iron absorption from the GI tract and increases iron sequestration. Why is this happening? Well, it turns out that we are trying to prevent microbes from getting a head start. If we make iron limiting, we can actually usually get a leg up on the microbes. So that's kind of the physiologic evolutionary purpose of this particular pathway. But if cancer elicits inflammation, making IL-6, now I've sequestered iron and I can't use it for making erythroid elements. So it's iron-restricted erythropoiesis. That inflammation is also making tumor necrosis factor, interleukin-1, and interferon gamma. Those things will actually act to diminish the erythropoietin response to anemia. So whenever we're anemic, we crank out more erythropoietin from our kidneys, but those particular inflammatory cytokines turn down the synthesis of red blood cells in response to the erythropoietin. So we have kind of cut off that particular arm too. There's more. So nutritional deficiencies, the effects of chemotherapy and radiotherapy, and marrow infiltration by a tumor will mean that the marrow cannot respond appropriately to EPO, even if all the other levels are appropriate. Iron-restricted erythropoiesis clearly also diminishes the marrow response to erythropoietin. And there's more. Renal insufficiency, due to chemotherapy or due to other kind of comorbidities, will result in less erythropoietin production, so therefore more anemia. And finally, we're going to be having, because of the effects of tumor, we may have bleeding due to leaky blood vessels. We may have hemolysis, rupture of red blood cells due to activation of the coagulation cascade, and there will be diminished red cell survival. All of these come together and result in anemia. So you can see that because of all the multiple boxes that we have on the screen here, that cancer can be a very common cause of low red cell count.